Hi guys, so we're going to try to finish up lists here today. So the first thing we're going to talk about is copying lists. So to make a copy of a list, you have to copy every element of the list. So you can do this in two different ways. One is you can create a new empty list and use a for loop to add a copy of each element from the original list to the new list. Or we can create a new empty list and concatenate the old list to the new empty list. So the reason for this is if I make a list and I make a second list variable and I make it point to the same to the original list, I say something like list2 equals list1. What's actually going to happen, instead of like in the other stuff that we've done where it actually makes a copy of the thing, with lists it's going to do what's called it's going to create what's called a reference, and the reference actually points to the same underlying list. And so let's look at an example of this because this can be a little confusing. Alright, so let's get rid of my example code here. Let's just print list1. Alright, so you look at my example code here, you see that I have list1 and I make it equal to some things. I add some things to it, and I'm going to print it to show you what it is, right? Then I'm going to say list2 equals list1. So I'm going to make these two things equal. So normally what you'd expect is just going to make a new variable, and that new variable is going to have a copy of what's in list 1. But in fact what happens is that they actually point to the same information. So we're going to show you that. So I'm going to go here, I'm going to set list 2 element 0. Remember, this is how we can set the particular value of an index. I'm going to set it to be hamster. Okay? Now I'm not going to print list 2, I'm going to print list 1, the original list. So I changed list 2 and I'm going to print list 1, and let's look at what happens when we do this. So you see that when we do this, we print list 1, it's originally test cat dog new thing. We set list 2 equal to list 1, we change the 0th element of list 2 to hamster. Now when we print it out, even though we're printing out list 1, we've changed list 1 by changing list 2, because what happens is these two variables point to the same underlying piece of data. And so when I change one, I change the other. So if I actually want to make a copy of this thing, what I would have to do is something like, I don't know, I could say something bracket plus list 1, right? Now, if I run this, you see list 1 is unchanged. If I print list 2, and I run this, you see that there's a list 1 and a list 2 now, because I created a new list 2 by forcing it. I made an empty list and I concatenated list 1 to the empty list. So empty list plus list 1 is just list 1, but it's a copy of list 1 because I made it make a new list by forcing it to concatenate, right? So list 1 and list 2 are now different, and you can see this from the printout that we've actually made a change to list 2 and didn't affect list 1 in this case. If we don't do this, if we just assign one to the other, then they point to the same data. If I change one, I change the other one. Alright, so we can use list elements in calculations. We can calculate the total of the numeric values in a list using a loop with an accumulator variable. So we could just, what they mean is something, let's just say, let's call it list 3 equals 1, 2, 3, right? So I would say sum equals 0 for I in list 3 colon sum plus equals I, right? Oops, I. And then print sum. So let's run this. So now you see that 6, which is 3 plus 2 plus 1, which is what we expected. So we did this in a little list. We have an accumulator variable. We loop over the list, and then we add things together. So if we want to average these things, we can divide the total of the number of things by the length of the list. We can also pass lists as arguments to functions. So if we have a function, we want to pass it in, we can pass a list as an argument to a function. So functions can also return a reference to a list. So we talked about returning simple variables in our functions, but we can also return lists. Lists are built-in type. It's not a problem to return them. It's not a problem to return non-built-in types, but lists can certainly be returned. So to save the contents of a list to a file, we can use the file object's write-lines method. So this does not automatically put a /n at the end of each item. If we want to put a /n at every item, we have to use a for loop, write each element, and then /n. To read the data from a file, use the file object's readLines method. We've talked about this in the section on files. So that's pretty much all we're going to cover with lists. My apologies, there seems to be a small fire incident going on outside. But this is pretty much what we're going to talk about with lists. If you're interested in lists, the book has the information on two-dimensional lists, which are not horribly complicated, but and then you can read about tuples. So tuples are basically just like lists, except you can't add things to them. So all the operators that have to do with adding or changing, those things don't work anymore. We can also, there's a nice little section here on plotting. I'm not sure how this sort of got stuck in here with lists. But there's a nice little section in here on plotting mathematical data, numeric data, with this Matplotlib, which is a Python library. You'd have to install this. You can read this yourself if you're a science type and you're interested in doing this. You know, go take a look. You can generate some pretty nice looking plots, but you can generate pretty nice looking plots in MATLAB too. It's up to you. This is all we're going to cover with lists, and we're going to talk about objects next week, and then we'll be done. All right, thank you all, and I hope you have a good afternoon.